In this video, we're going to learn about rational expressions. We'll start by learning how to determine the domain of a rational expression, and then we will learn how to simplify, multiply, and divide rational expressions. For this video, I will assume that you have a basic understanding of how to factor. If you feel that you need more of an introduction to factoring or a review of factoring, please watch my chapter 4.4 through 4.7 videos. You'll want to make sure that you have a good understanding of how to factor before watching this video. Let's start with the definition of a rational expression. A rational expression is simply a fraction in which the numerator and denominator are polynomials. A polynomial is simply an expression that consists of variables, coefficients, and the operations addition, subtraction, and multiplication. Here are three examples of rational expressions. Again, a rational expression is just a fraction that involves variables. Next, we're going to learn how to determine the domain of a rational expression. When you're asked to find the domain of an expression, such as these expressions here, the domain is the set of values that the variable may assume. So before we fill out this blank here, let's look at example A. For part A, we're asked to determine the domain of this rational expression. The domain is the set of values that the variable x may assume. So I like to think of the domain as the collection of all x values that are allowed. In other words, what values are we allowed to plug in for x? Well, there are infinitely many values we could plug in for x. Here are some examples. You could plug 2 in for x. If you plug 2 in for x and compute the numerator divided by the denominator, you'll get a valid output. You could plug 15 in for x, and when you compute the numerator divided by the denominator, you'll get a valid output. You could plug a fraction like 5/4 in for x. You could plug an irrational number like the square root of 2 in for x. You could plug a repeating decimal in for x. And I'm going to draw a dot, dot, dot here because we can plug infinitely many values in for x, and when we compute this expression, we'll get a valid output. In fact, we are allowed to plug in any real number for x except for one number. So the domain includes all real numbers except for one number. What is the one number that gives us an undefined value when it is plugged in for x? That would be the value that makes the denominator equal to 0. Because in mathematics, the denominator is not allowed to equal 0. If your denominator is 0, the value of your expression is undefined. If x is 10, our denominator would equal 0. Therefore, the one value of x that's not allowed is 10. And I'm going to put 10 outside our domain because the domain includes all real numbers except for 10. Now we're asked to write our final answer using set builder notation. Remember, with set builder notation, we start with this general outline, and then we'll describe the domain in this blank here. Now the domain is the values of x that are allowed. When we're trying to describe the domain, it would be impossible to describe all of the values of x that are allowed because there are infinitely many. So a much easier way to describe the domain is to simply describe the one value of x that is not allowed, which is 10, because if you plug 10 in for x, that makes the denominator 0. So to describe the domain, we can say that x is not allowed to equal 10. So this answer says that the domain is the set of all x values such that x does not equal 10. Another way to state that is that x can be any real number except 10. So let's go back and fill in this blank here. To find the domain of a rational expression, we exclude all values of the variable that cause the denominator to equal 0. So for problem 1a, the value of x that was not allowed is 10, because if x is 10, then we have 10 minus 10, which gives us 0 in the denominator. Let's take a look at example B. Now again, we're trying to find the domain of this rational expression. If we're looking for the domain, we're trying to find what values are we allowed to plug in for a. The answer is that we're allowed to plug in any value for a except the value or values that make the denominator equal to 0. Now keep in mind, when you have a fraction, the numerator can equal 0. That's allowed in mathematics. But in math, the denominator cannot equal 0 because when your denominator is 0, your expression is undefined. So when you're determining the domain, you only want to exclude values of the variable that cause the denominator to equal 0. A common mistake is that students will also try to find the values that make the numerator equal to 0, but you do not need to do that. For problem A, we could mentally figure out what value of x made the denominator 0. For part B, it's difficult to mentally figure out what values of a make the denominator 0. So if you're having trouble mentally determining when the denominator is 0, we can write ourselves a simple equation. So we want to know, when is the denominator equal to 0? Let's write that as an equation. So we'll write the denominator, a squared minus 2a minus 8, and we want to know, when is that equal to 0? Now we've created an equation. In fact, this is a quadratic equation since we see an a squared term. In my chapter 4.8 video, we learned how to solve quadratic equations just like this. To solve quadratic equations, we first make sure that it's written in standard form. This quadratic equation is written in standard form. Next, we want to factor. So whenever we factor, we first need to check for a GCF. This particular trinomial has no GCF. Next, to factor a trinomial, we need to find the two numbers that multiply to give us a times c, where a is the coefficient of the squared term and c is the constant. So that would be 1 times -8, which gives us -8. We need those same two numbers to add to give us b, where b is the coefficient of your middle term, which is -2. The two numbers that work are -4 and 2. I noticed that the coefficient of the squared term is 1. If that's the case, once you have these two numbers, you can insert them in your parentheses to write your factored form. So we'll start with our parentheses. Since our variable is an a, we'll put an a in the first position in each parenthesis, and then we'll insert these green numbers in the blanks. Now, keep in mind, our equation is equal to 0, so we need to set the factored form equal to 0. So now we've factored this expression here. Once you've factored an equation, if you want to solve that equation, the next step is to set each factor equal to 0. So let's start by setting this factor equal to 0. So we'll set a minus 4 equal to 0, and then we'll set this factor equal to 0. So we set a plus 2 equal to 0. Now we just need to solve these two equations. To solve this equation, we can add 4 to both sides, and that will leave us with a is equal to 4. To solve this equation, we'll subtract 2 from both sides, and that will leave us with a is equal to -2. Now, let's remember what we were trying to find. We were trying to figure out, when is the denominator equal to 0, because that will tell us the values of a that are not allowed. Because remember, in mathematics, the denominator cannot equal 0. So this is the denominator here. So I'm going to add a slash through here because the denominator can't equal 0. And so I'm going to add a slash through these equal signs as well, because these are the values that make the denominator equal to 0, and those values aren't allowed. So now that we found the values that make the denominator equal to 0, we can write our domain. To write the domain using set builder notation, we'll start with this general set builder outline. When we're asked to determine the domain, we're looking for what values of a are allowed. It would be impossible to list all of the values of a that are allowed, because there are infinitely many values that we are allowed to plug in for a. So when you're stating the domain, instead of trying to list the infinitely many values of a that are allowed, it's much easier to list the values of a that are not allowed. So we can say that a cannot equal -2 and a cannot equal 4. So this answer says that the domain is the set of all a values such that a does not equal -2 and a does not equal 4. Another way to state that is that a can be any real number except -2 and 4. Lastly, let's find the domain for part C. So when you're asked to find the domain, you're being asked what values of x are allowed. And the answer is typically x can be any real number except for the values that make the denominator equal to 0. So when we're determining the domain of a rational expression, we want to ask ourselves, when is the denominator, x squared plus 1, equal to 0? Now this is another quadratic equation because we see it has an x squared term. In chapter 4.8, we learned to solve quadratic equations by factoring. First, we would check for a GCF, but there is no greatest common factor here. Next, we want to factor, but we run into an issue here. We have two perfect squares, x squared and 1, and we have an addition sign in the middle. So this is the sum of two squares, And we learned in my 4.6 video that the sum of two squares cannot be factored. So this cannot be factored. So how do we figure out when this is equal to 0? Well, let's logically think through this. Whenever you square a number, you get a positive result. So no matter what you plug in for x, when you square it, you'll get a positive number. So a positive number plus 1 will give you another positive number. You will never get 0. So this expression here will never equal 0. So since the denominator is never 0, there are no values of x that are not allowed. So when stating the domain for our final answer, we'll use the set builder notation. And since there are no values of x to exclude, we can say that x is any real number. Next, we're going to learn how to simplify a rational expression. Here are the two steps that we're going to follow when we're asked to simplify a rational expression. Step 1, we're going to factor the numerator and denominator completely. Step 2, we're going to cancel common factors that appear in both the numerator and denominator. Let's take a look at an example. For problem 2 here, we're asked to simplify each rational expression. Let's start by simplifying this rational expression here. When you're simplifying, step 1, we want to factor the numerator and the denominator. Let's look at the numerator first. The first step in any factoring problem is to check for a greatest common factor. There is no greatest common factor for this expression in the numerator. In fact, this expression in the numerator cannot be factored at all. So since the numerator can't be factored, I'm going to start by just copying down the numerator. Next, let's see if we can factor the denominator. The first step in any factoring problem is to check for a greatest common factor. The greatest common factor of this denominator is 5x. So we need to factor out the greatest common factor. We'll put the 5x outside of parentheses. 5x times x will give us our 5x squared, and 5x times a positive 3 will give us our 15x. This denominator cannot be factored any further, so we factored the numerator and denominator as much as we can. We've completed step 1. For step 2, we cancel common factors that appear in both the numerator and the denominator. So we're going to look at this factored form here. Notice there is an x plus 3 in the numerator and an x plus 3 in the denominator. So we can cancel those x plus 3's. Now, what are we left with? Let's first examine the numerator. Before we canceled the x plus 3, we could put parentheses around it, and that wouldn't change anything. In fact, we could also add a 1 here. 1 times x plus 3 is the same as x plus 3, so we haven't changed anything in the numerator. But the reason that's helpful is we can see when we cancel the x plus 3's, what we're left with in the numerator is this implied 1. So for our final answer, we'll write 1 in the numerator, and in the denominator, we canceled the x plus 3, and all that we're left with is 5x. So this is our final simplified answer. We've taken the original rational expression, and we've simplified it here. Let's take a look at the next example. Again, we're asked to simplify this rational expression, and whenever we're asked to simplify a rational expression, we'll follow these two steps here. Step 1, we want to factor the numerator and the denominator. I'm going to start by factoring the numerator. So I've started by copying the numerator down here. To factor this numerator, we first check for a greatest common factor. There is no greatest common factor. So next, we need to find two numbers that multiply to give us negative 6 and then add to give us 1. Those two numbers are 3 and negative 2. So now let's write our answer in factored form. We'll start with our parentheses. We'll put an x in the first position in each parenthesis, and then we'll put a plus 3 in one parenthesis and a minus 2 in the other. Now we factored the numerator right here. Next, let's factor the denominator. I've started by copying the denominator down here. To factor this denominator, we first check for a GCF. There is no GCF. Next, we need to find two numbers that multiply to give us 4, and then add to give us negative 5. The two numbers that work are negative 4 and negative 1. Now we learned how to factor trinomials like these in chapter 4.5. We learned that when the coefficient of the x squared term is a 1, once you find these two green numbers, you just insert them in the parentheses and you have your factored form. When you're factoring a trinomial where the coefficient of the squared term is not 1, once you find these two green numbers, you cannot just insert them in the parentheses and be done, like we did up here. Instead, we learned three methods. You can factor by grouping, use the box method, or use the factor and divide method. My favorite is always the factor and divide method, so that's what I'm going to use here. For the factor and divide method, we'll start with our parentheses. Since the coefficient of the squared term is a 2, we'll put a 2x and a 2x in the first position in each parenthesis. Then we'll insert these green numbers in the blanks. So we'll put a -4 in one parenthesis and a -1 in the other. Now I call this the factor and divide method because once you write this in factored form, we now have to divide. And we're going to examine each parenthesis and divide by that parenthesis GCF. The GCF between 2x and 4 is 2, so we'll divide this parenthesis by 2. And the GCF of 2x and 1 is just 1. So dividing by 1 doesn't change anything, so we don't need to divide this parenthesis. If we divide each term in this parenthesis by 2, 2x divided by 2 will give us x, and -4 divided by 2 will give us -2. Then we can just bring this parenthesis down. And now we've written this denominator in fully factored form. Now that we've factored, we want to rewrite this original expression in factored form. We factored the numerator here, so I'm going to copy this factored form of the numerator down into our numerator here. We factored the denominator here, so I'm going to copy this factored form of the denominator into our denominator here. Now we've completed step 1. We've rewritten the original problem in factored form. For step 2, we examine our factored form and we cancel any common factors that appear in both the numerator and the denominator. I notice that there's an x minus 2 in the numerator and the denominator. So let's cancel that x minus 2. That leaves us with x plus 3 in the numerator and 2x minus 1 in the denominator. And we could leave the parentheses around the numerator and the denominator, but when your numerator or your denominator only has one factor, you do not need to use parentheses around that factor. So here's our final answer. We've simplified this original rational expression to get this answer here. Let's take a look at two more examples. Again, for these examples, we want to simplify the rational expression. Let's look back at the steps for simplifying a rational expression. When you're asked to simplify a rational expression, step 1, factor the numerator and denominator completely, and step 2, cancel common factors that appear in both the numerator and the denominator. So for problem C here, step 1 for simplifying is to factor the numerator and the denominator completely. Let's first factor the numerator. I've copied the numerator down right here. Now notice this expression is not written in standard form, because in standard form, we should have the x squared term written first and the constant last. I recommend before you try to factor, always write your expression in standard form. So for standard form, we'll put the x squared term first, and it's a negative x squared, so we'll write negative x squared first, and then we put the constant last, and since it's a positive 49, we'll write plus 49. Now that we've written this expression in standard form, we can now factor. The first step of any factoring problem is always to check for a greatest common factor. Now that it's written in standard form, it's clearer what the greatest common factor is. Because remember, when your first term in standard form is negative, in other words, when the variable with the highest exponent is negative, you must have a greatest common factor, and that greatest common factor must be negative. So for our greatest common factor, I'm going to start with a negative. Now, what's the largest number that multiplies into both x squared and 49? That would be 1. Normally, if your GCF is 1, we say that there is no GCF. But if your first term in standard form is negative, then you have to have a GCF and it has to be negative. So the only negative GCF that we can use here will be -1. Now, let's factor out the -1. -1 times x squared will give us negative x squared, and -1 times a -49 will give us our positive 49. Now we've factored out the greatest common factor. Now we're going to focus on factoring this binomial. If we examine this binomial, notice that we have two perfect squares. X squared is a perfect square and 49 is a perfect square, and we have a subtraction sign in the middle. When that's the case, we use the difference of two squares formula, which is a minus b times a plus b. Now again, in this video, I'm going to factor pretty quickly since we've had so much practice factoring. But if you'd like an introduction or review of how to use the difference of two squares formula, please watch my chapter 4.6 video. If we use the difference of two squares formula to factor this binomial, that will give us x minus 7 times x plus 7. And then we need to make sure to include our GCF, negative 1. So we've factored the numerator right here. Next, I'm going to factor the denominator. So I'll start by copying this denominator right here. The first step of factoring this expression here is to check for a greatest common factor. And the greatest common factor of this expression would be x. So we'll write the x outside of parentheses, and then we'll think through the distributive property. What would we have to put inside these parentheses so that when we distribute the x, we get this expression here? X times x cubed will give us x to the fourth. X times a positive 7x squared will give us 7x cubed. X times negative 5x will give us negative 5x squared. And x times negative 35 will give us negative 35x. Now that we've factored out the greatest common factor, we're going to, of course, include the greatest common factor in our final answer, but we can ignore it just for the time being as we focus on factoring this expression here. Notice this expression has 4 terms. In my 4.4 video, we learned that whenever you have 4 terms, you factor by grouping. So I'm going to speed up the video as I factor this by grouping, but if you'd like an introduction or review of factoring by grouping, please watch my chapter 4.4 video. Now we've factored the denominator using the factor by grouping method, and our final factored form is written here. Let's rewrite this original expression in factored form. So we factored the numerator right here. So I'm going to copy this factored form down in the numerator right here. Then we factored the denominator right here. So I'm going to copy the factored form of the denominator down here. Now we've written our original problem in factored form. So we've completed step 1. For step 2, we're going to cancel. I see that the factor x plus 7 appears in both the numerator and the denominator. So let's cancel x plus 7. Now let's write our final answer. In the numerator, we're left with negative 1 times x minus 7. So I've written that here. And in the denominator, we're left with x times x squared minus 5. So I've written that in the denominator here. Now there are several different correct ways you could write your final answer here. If you'd like to distribute the negative 1 in the numerator and the x in the denominator, you can and you would be correct, but you're not required to do that. So to avoid any extra work, I would recommend that you leave your answer in factored form like this and you don't distribute. There are also a couple other ways we could write our final answer. When you have 1 for your coefficient, you don't have to write your 1. So we could instead write this numerator as negative x minus 7. Notice we left out the 1 because the 1 is implied. And then I'll copy down our same denominator. Yet another way we could write our final answer is, remember with fractions, if you have a negative in your numerator, you can move that negative out front and it's equivalent. So instead of writing the negative in the numerator, we could put the negative out front of our fraction. So we'll still have the x minus 7 in the numerator, but we moved the negative out front, and then we'll still have the exact same quantity in the denominator. So these are not all of the ways that you could write your final answer. There are more, but these are 3 of the most common ways that you could write your final answer. Let's take a look at one more example. And again, the instructions for this example are to simplify. Whenever we're asked to simplify, step 1 is to factor the numerator and the denominator. I encourage you to pause this video and try this problem on your own, and then once you're ready, play the video to check your answer. I'm going to speed up the video as I factor this numerator, but if you feel that you need extra review of factoring trinomials, please watch my 4.5 video. So I've factored the numerator here. Next, let's factor the denominator. I've copied the denominator down here. Now notice, the denominator is not written in standard form. So before you attempt to factor this, I recommend you rewrite it in standard form. To write this in standard form, we put the variable first and the constant last. So let's write the negative 3w first, and then we'll write the constant last. Since this is a positive 5, we'll write plus 5. Now this is written in standard form. Notice the first term in standard form is negative. When that's the case, you must have a greatest common factor and it must be negative. So I'm going to start by writing a negative for our GCF. Now, the only number that multiplies evenly into both 3 and 5 is 1. So the only GCF we can have here is negative 1. So now we have to factor out the negative 1. Negative 1 times 3w will give us negative 3w, and negative 1 times a negative 5 will give us our positive 5. And we cannot factor this any further, so we've now written the denominator in factored form. Now that we've factored both the numerator and the denominator, let's write the numerator and denominator in factored form here. So the factored form of the numerator is this, so I'll copy this down in the numerator here. The factored form of the denominator is this expression here, so I'm going to copy this expression into the denominator here. Now that we've rewritten our original problem in factored form, we've completed step 1. For step 2, we cancel any common factors that appear in both the numerator and the denominator. I notice that 3w minus 5 appears in both the numerator and the denominator, so we can cancel that factor. Now we're left with w plus 5 in the numerator, and all that we're left with is negative 1 in the denominator. Now be careful, because we can actually simplify this answer. In math, we do not like to leave our final answers with the negative in the denominator. If you have a negative fraction, we like to write the negative either out front or in the numerator. So for your final answer, don't leave this negative in the denominator. Either move it out front or into the numerator. I'm going to move this negative up to the numerator. So I've moved this negative up to the numerator, shown here. Now be careful. When you move the negative to the numerator, you have to add parentheses around the numerator to ensure that you're applying the negative to the whole numerator. Now we can still simplify this further because dividing by 1 does not change the value of your expression. So if you have 1 in your denominator, you don't need to write that 1 for your final answer. So for our final answer, we can get rid of that 1 in the denominator and write our answer like this. If you'd like to take an extra step and distribute this negative, you can, and that would leave you with negative w minus 5. Distributing this negative to get this answer here is an extra step and it is not required. But if you do distribute the negative, your answer will still be correct. I created this page here after I saw students making the same mistake over and over and over again. So hopefully after we discuss this page, you'll be able to avoid making that mistake. So we need to understand the difference between a factor and a term. Let's start with a factor. Factors are numbers or algebraic expressions that are multiplied together. So let's identify the factors in these examples down here. Factors are quantities being multiplied together. So in this example here, the 2 and the 3 are factors because they are quantities being multiplied together. We have 2 times 3. In this example here, since this quantity is being multiplied by this quantity, these two quantities are factors. Again, factors are quantities that are being multiplied together. So here we have 2 times x times this quantity. So we have 3 factors here, the 2, the x, and this quantity. Here we could view this as 3 factors, x squared, the quantity 5x minus 1, and the quantity 2x plus 3. And in this example here, we have 2 factors. Next, let's define a term. Terms are quantities separated by addition or subtraction signs. So let's identify the terms in these examples here. Notice these 3 quantities are separated by addition signs. So these 3 quantities are called terms. These 2 quantities here are separated by an addition sign, so these 2 quantities are terms. Here we have 3 quantities being separated by addition and subtraction signs. So these 3 quantities are terms. And for our last example, These two quantities are separated by a subtraction sign, so these two quantities are both terms. Now, hopefully that helped you to understand the difference between a factor and a term. Now, when you're simplifying a rational expression, you can cancel common factors. And if we look back at our previous work, we can see that that's exactly what we've been doing. Here we cancel these common factors, and here we cancel these common factors. You cannot cancel common terms or parts of terms. This is one of the most common mistakes, is that students will cancel terms or parts of terms. So these three examples illustrate very common mistakes. Let's look at this first example here. In this first example, notice the student canceled the x's. This is wrong because notice this x is a term. Remember, a term is a quantity being separated by an addition or a subtraction symbol. This addition symbol separates these two terms. So the student here has canceled a term. Remember, you cannot cancel common terms. So this is not correct. Here's another example of a mistake. Notice this student canceled the x squares and canceled the x's. That's very tempting, but that is incorrect. Notice in the numerator, we have these addition symbols separating the terms. So this is a term, this is a term, and this is a term. Same thing in the denominator. These addition symbols are separating our terms. So this is a term, this is a term, and this is a term. When the student canceled the x squares, they are canceling a term. Remember, you cannot cancel common terms. When the student canceled the x's, they canceled a part of a term. Remember, you cannot cancel parts of terms. So this is incorrect. If you wanted to correctly solve this, you would have to factor the numerator and factor the denominator. And once you've factored, you would cancel common factors. Let's take a look at this last illustration of a mistake here. Notice the student canceled the x's. Let's start with the x in the denominator. In the denominator here, the x and the 7 are terms since they're being separated by an addition symbol. We're not allowed to cancel terms, so we can't cancel this x. In the numerator here, this quantity x minus 8 is a factor. Whole factors can be canceled, but you can't cancel just one part of a factor. So we could only cancel this whole factor. We can't cancel just a part of the factor x. So again, these are three examples of very common mistakes. Make sure you are only canceling common factors. You cannot cancel common terms or parts of terms. Now we've learned how to simplify a rational expression. Next, we're going to learn how to multiply a rational expression. When the instructions ask you to multiply a rational expression, for step 1, we factor completely. For step 2, we combine the numerators and the denominators, and we'll see an example of this shortly. And for step 3, we cancel common factors that appear in both the numerator and the denominator. So let's take a look at an example. We're asked to multiply the rational expressions. So when you're multiplying rational expressions, we'll follow these 3 steps here. Step 1, we have to factor completely. So we're going to factor each numerator and we're going to factor each denominator. I'm going to start by factoring this numerator here. And remember, the first step whenever you're factoring is to check for a greatest common factor. The largest number that multiplies into 28 and 42 is 14. And both of these terms have an x. So remember, when you're identifying the greatest common factor, you always pick the x with the smallest exponent. So between x cubed and x squared, we put x squared in our GCF. Now that we've identified the GCF, we have to factor out the GCF. So 14x squared times 2x will give us 28x cubed, and 14x squared times a negative 3 will give us negative 42x squared. Now that we've factored out the GCF, this expression here cannot be factored any further. So we factored this numerator as much as we can. Now I'm going to speed up the video as I factor this denominator, this numerator, and this denominator. I encourage you to pause the video, try to do the factoring on your own, and then when you're ready to check your answers, play the video. Okay, so I factored this numerator here, I factored this denominator here, I factored this numerator here, and I factored this denominator here. Now that we've factored each numerator and each denominator, we have to rewrite this original problem in factored form. So this numerator in factored form is this expression here. So I'm going to write this expression in the numerator here. This denominator in factored form is this expression here. So I'm going to copy this expression in the denominator here. The factored form of this numerator is this expression here, so I'll copy this expression in this numerator here. And the factored form of this denominator is this expression here, so I'll copy this expression into this denominator here. Now that we've rewritten the original problem in factored form, we can move on to step 2. For step 2, we combine the numerators and denominators. I want to look at a quick example so that we understand the reasoning behind step 2. If we're multiplying the fractions 2/5 times 3/4, whenever you multiply fractions, you multiply the numerators, so we would take 2 times 3, and you multiply the denominators, so we would take 5 times 4, and that would leave us with 6/20. And with fractions, we always want to simplify our answers, so to simplify this, we would divide the numerator and the denominator by 2, which would give us the final simplified answer, 3/10. Now step 2 we call combining. We combined the numerators when we took 2 times 3, and we combined the denominators when we took 5 times 4. This is exactly what we're going to do with our rational expressions. So these are fractions, and when we multiply fractions, we multiply or combine the numerators. So notice I've combined the numerators. I've taken this numerator and multiplied by this numerator. We're going to do the same with the denominators. We want to combine the denominators. In other words, we're going to multiply this denominator times this denominator. So I've started by writing this denominator, and then I'm going to multiply by this denominator. Now, step 2 can actually be combined with step 1. You don't have to rewrite step 2 as a whole separate step. Notice once we completed step 1, we could have just extended this line over, and that would get us to step 2. So if you don't want to write a whole separate step for step 2, just go ahead and look at your final answer for step 1 and extend this line over, and that will give you this exact same expression that we've written here. Step 3, we're going to cancel common factors. Whenever you're dealing with fractions, you always have to simplify your final answer. And step 3, where we're canceling, is just a form of simplification. To start, I see the factor 2x minus 3 in the numerator and denominator, so let's cancel out that common factor. I also see the factor x plus 1 in the numerator and the denominator, so let's cancel that common factor. If you're comfortable, you can continue canceling this expression, but I'm going to write what we have left before I continue to cancel. So in the numerator, we're left with 14x squared times x minus 5. And in the denominator, we're left with negative 1 times 7x times x minus 7. Notice that I've multiplied the negative 1 times the 7x to give us negative 7x. Now we can do some more canceling here. 14 divided by negative 7 equals negative 2. Now what about x squared and x? It may help for you to rewrite x squared as x times x. When you rewrite x squared as x times x, it becomes a little bit clearer how to cancel here. Since we have an x in the numerator and the denominator, we can cancel one x here. That will leave us with x times x minus 5 in the numerator, and all that we have left in the denominator is x minus 7. So this is our final simplified answer. Now you could write this final answer a couple different ways. You could take this negative and move it out front. If you'd like to take an extra step, you could distribute the negative 2x, and you would be correct, but that's an extra step and it's not required. Let's look at one more example where we're multiplying rational expressions. Remember, if the instructions say to multiply, we follow these 3 steps here. So step 1, we want to factor completely. We're going to factor each numerator and each denominator. Let's start by factoring this numerator together. The first step, whenever you're factoring, is to check for a greatest common factor. There is no GCF here. Next, notice we have 2 terms. If you have 2 terms, we call that a binomial. And when you're factoring a binomial, you have to decide if you're dealing with perfect squares or perfect cubes, because that will tell you what formula to use. x cubed is a perfect cube, and 8 is also a perfect cube. So it looks like we're dealing with perfect cubes here. And since we have a minus sign in the middle, we're going to factor using the difference of two cubes formula, which looks like this. To use this formula, we just have to find a and b and plug it into this formula. To find a, I recommend that you rewrite this first quantity as some quantity cubed. To get x cubed, we would just have to cube x. To find b, I recommend that you write this 8 as some quantity cubed. To figure that out on your calculator, you could take the cubed root of 8. If you type the cubed root of 8 into your calculator, you'll get 2. So 2 cubed gives us 8. Now a is the quantity inside these first parentheses, so a is x, and b is the quantity inside these second parentheses, so b is 2. Now that we've figured out our a and our b, I'm going to start by copying this formula down here. And then I'm going to plug in x for a into our formula, and I'll plug in 2 for b into our formula. That leaves us with this expression here, and I'm going to simplify just by squaring the 2. And that gives us this final factored form here. Next, I'm going to go through and factor the denominator here, and this numerator and this denominator. Again, I recommend that you pause the video, try the factoring on your own, and then play the video to check your answer. Now to factor this denominator here. First, I factored out the greatest common factor, which was x. Next, I focused on this trinomial here. To factor this trinomial, we need to find two numbers that multiply to give us 4, and those same two numbers need to add to give us 2. Notice there are no two numbers that work. That means that this trinomial is prime. Now, this denominator could still be factored because we can factor out a GCF. It just can't be factored any further than this since this trinomial was prime. So this would be the fully factored form of this denominator. All that we can do is factor out the GCF x. Now that we've factored each numerator and each denominator, we want to rewrite this original problem in factored form. So the factored form of this numerator is this expression here. So I'll write that in this numerator here. The factored form of this denominator is this expression here. So I'll write this expression in the denominator here. The factored form of this numerator is this expression here. So I'll write this in the numerator here. And the factored form of this denominator is this expression here. So I'll write this expression in the denominator here. Now that we've rewritten this original multiplication problem in factored form here, we've completed step 1. For step 2, we combine. When you multiply fractions, you multiply or combine the numerators, and you multiply or combine the denominators. For step 2, I recommend that you don't bother writing it as a whole separate step. I recommend that you just look up at your step 1 and draw this line over to connect these two. Now we've combined it, so we're taking this numerator times this numerator, all written in one line, and we've taken this denominator times this denominator, all written in one line. For step 3, we're going to cancel any common factors. To start, I notice that the factor x plus 5 appears in both the numerator and the denominator, so I've canceled that common factor. I also notice that the factor x squared plus 2x plus 4 appears in this numerator and this denominator, so we can cancel that common factor. And it looks like we've canceled all of the common factors. So now let's write our final answer. In the numerator, we're left with x minus 2 times x minus 2. And in the denominator, we're left with 2x minus 3 times x. Now this final answer is correct, but we could write it in condensed form. Since we have x minus 2 times x minus 2 in the numerator, we could rewrite this numerator as x minus 2 squared. And then I'm going to copy this denominator over here. And this is our final answer. Now I recommend that you leave your answer in this factored form. If you want, you could take the extra step of foiling out this numerator by foiling this expression here And you could distribute the x in the denominator, and your answer would be correct, but you would be taking some extra steps that aren't required. Now we've learned how to simplify a rational expression. We've learned how to multiply a rational expression. Last, we're going to learn how to divide a rational expression. I'm going to recommend that you start by rewriting this division symbol using the other division symbol. I'll show you what I mean. So I'm going to start by copying down this whole expression here. Okay, so I've copied this expression down here. Now instead of writing the division symbol like this, I'm going to rewrite this orange division symbol using this division symbol. Then I'm going to copy this expression over here. Okay, so this problem is equivalent to this problem. In this problem, we're taking this quantity divided by this quantity. We've just rewritten that as this quantity divided by this quantity. Now, how do we divide fractions? Let's start by looking at a simpler example. If we're asked to divide 2/3 by 3/4, to divide fractions by hand, we can use the flip and multiply approach. The flip and multiply approach says, keep the first fraction exactly as written, so we'll keep the 2/3. But then we change the division symbol to a multiplication symbol, and we flip the second fraction. So we're going to flip the second fraction to 4/3. Now we'll multiply or combine the numerators. So we'll take 2 times 4 to get 8. And we'll multiply or combine the denominators. So we'll take 3 times 3 to get 9. And the last step would be to check to see if you can simplify. This fraction here cannot be simplified. So now we know that when we're dividing fractions, we flip and multiply. And when you use the flip and multiply approach, we copy down the first fraction exactly as written. Then we change the division symbol to a multiplication symbol, and we're going to flip this fraction. So the numerator will become x squared plus 4x minus 12, and the denominator will become x cubed plus 2x squared. So we've used the flip and multiply approach to rewrite this as a multiplication problem. So I'm actually going to adjust these instructions. If you encounter a division problem like this, step 1, you're going to want to rewrite the division problem as a multiplication problem. Using this flip and multiply approach that we used here. Now that we've completed step 1, now we want to multiply. And we learned the steps for multiplying on the previous pages. Let's look back at the steps for multiplying. If you're multiplying a rational expression, step 1, factor completely, step 2, combine, and step 3, cancel common factors. So now that we've rewritten this as a multiplication problem, we're going to factor. And for the remainder of the problem, we're not going to focus on this expression or this expression. We're going to focus all of our attention on this multiplication problem here. So let's start by factoring this numerator. Whenever you're factoring, the first step is always to check for a greatest common factor. The greatest common factor here is x. So let's factor out the x. Now, this expression cannot be factored any further. So we've factored this numerator as much as we can. Next, let's factor this denominator. So I've started by copying this denominator down here. Now notice this numerator and this denominator look very similar, but you'll have to be careful because they're factored differently. This expression here has no GCF. So now we have to figure out if we can factor this further. Well, notice we have a binomial. And with binomials, we always check to see if you're dealing with perfect squares or perfect cubes. X squared is a perfect square, and 4 is a perfect square. So it looks like we're dealing with perfect squares, and since we see a minus sign in the middle, we're going to use the difference of two squares formula, which looks like this. If we use the difference of two squares formula to factor this, we end up with this expression here. Next, I'm going to factor this numerator. So I factored this trinomial here. And lastly, let's factor this expression here. The greatest common factor between x cubed and 2x squared is x squared. So let's factor out the GCF. And this expression here cannot be factored any further. So for this denominator, all we can do is factor out the GCF. Now let's rewrite this multiplication problem using the factored form. So the factored form of this numerator is this. So I'll write this in the numerator here. The factored form of this denominator is this, so I'll write this in the denominator here. The factored form of this numerator is this, so I'll write this in this numerator. And the factored form of this denominator is this, so I'll write this in the denominator here. Now, after you've rewritten your multiplication problem in factored form, the next step is to combine. You can write this as a separate step, or a quicker way is to just connect these two lines here. Now we're multiplying this numerator times this numerator and this denominator times this denominator. And last, with any fraction, you always need to check at the end to see if you can simplify. And we simplify by canceling common factors. To start, I see x minus 2 in the numerator and x minus 2 in the denominator, so I've canceled those two factors. And if it helps, we can rewrite x squared as x times x. That makes it a little bit easier to see that we have an x in the numerator and an x in the denominator that can be canceled. Now let's see what we're left with. In the numerator, we have x minus 4 times x plus 6, and in the denominator, we're left with x plus 2. For this x squared, we canceled one of the x's, so we're only left with 1x, and then we're left with another x plus 2. And here, since we're left with x plus 2 times x plus 2, we can write that in condensed form as x plus 2 squared. And then we're still left with this x, and then I'll copy over this numerator. And this is our final answer.